Now, the most general case in polarization is elliptical polarization. In that case, the magnitude in the y direction and the magnitude in the x direction are not equal. So if they are equal, then that defaults to circular polarization. And what we have here is we have an ellipticity angle psi and chi, and then we have our angle of inclination psi, which is referred to as psi sub naught. So psi naught is the auxiliary angle. It's what's referred to in elliptical polarization. It has to lie between 0 and pi over 2. And if the cosine of psi is greater than 0, then gamma, which is the axis that the axis of the ellipsoid makes with the x-axis, is greater than 0. And the cosine of del is less than 0, then gamma is less than 0, which would mean this entire ellipse would be tilted in the other quadrant. Sorry. So positive values of chi correspond to the sine of del greater than 0 are associated with left-hand rotation. Negative values of chi are associated with right-hand rotation. So you can see how the tangent is determined, and then a lot of what happens depends on what is the value of delta, the phase difference between the x and y components, as well as what's the difference between the magnitude in the y direction and the magnitude in the x direction. So this is just a simple example that's asking us to determine the polarization state of a plane wave with the following electric field. So you can see that we have an x component and a y component. We have two phase shifts, and to really compare those two phase shifts, we then need to go to the cosine function for both of those. You can see that we have the x component and the y component, and then we find the corresponding phasor field by basically by substituting in using Euler's relation. And when you do that, you end up with an x and y components with their respective phase shifts. So from there, you can calculate psi naught, and then you can also calculate the tangent of 2 gamma, so that you can get the necessary information to determine the polarization state. So if you now find the sine of 2 chi, you get that from the sine of 2 psi naught, sine of delta, and that ends up to be 0.93, or chi is equal to 34 degrees. So let's go back. The magnitude of chi indicates the wave's elliptically polarized, and the fact that it has positive polarity specifies that it has left-handed rotation. So this is just an example or an illustration of what elliptical polarization looks like. In this example, we're letting time run, and as time runs, then the point of the tip of the electric field vector is tracing out this ellipse. In this particular case, it is traveling in the z direction, which is toward the viewer. Different example. So in the next set of lectures, we will talk about plane waves in lossy media, which is a little bit of a different thing compared to plane waves in lossless media.